Fire protection systems. What are some characteristics of fire detection systems? Well, they're designed to tell you about things that are happening away from where you're at. If you're flying a 172 and there's a fire, you can usually tell if it's an electrical fire under the instrument panel or the engine is on fire. You're going to be able to notice. But in a transport category jet, big turboprop, and a lot of other, say small turbojets, small business jets, small turboprops, you may be too busy doing other things, or things that could catch on fire could be too far away for you to notice rather easily. So you need a system that'll tell you what's going on far away from where you're at. These systems are almost always associated with, or almost always have, some type of a test. You push a button during pre-flight or during taxi to make sure that the system is operating before you take off. And here's a test panel. I think it's off an A320, and you can actually push these buttons to see if the test will work. And you're going to get lights and or buzzers to let you know that. And it might not be a very intricate or sophisticated system. It just might be a temperature gauge, like on a NiCad battery would tell you that the battery's overtemping. Might be warning lights. It might have bells as well. These are general characteristics of fire detection systems. We're just going to be talking about airframe fire protection systems in this class. We're not going to be talking about engine fire detection systems much, if at all. And where can you find these detectors? You can find them on the outside of bleed air ducts. Obviously, inside of the bleed air ducts are going to be hot because the air is coming off of a jet engine. But if it leaks out, that's when it's going to be an issue. So you're likely to have on aircraft with a pneumatic system, on turbine engines, is to have some type of fire or overheat warning system for the pilots to tell them that there's a duct leak and things outside the duct might be getting hurt. For instance, here's an A320, and here's the APU, and there's a duct, and right alongside it, the dotted line, that is the sensor. Here's a duct coming out of the engine, and here's a duct running up and down the wing, and here is this dotted line is one sensor loop, and here's another sensor loop inside of the engine. Same thing for the opposite side. So if there was a leak anywhere in this duct right here, it would make this loop come on, and in the cockpit all you would know is that somewhere between the APU and this valve right here that there's a duct leak. So you're probably going to shut down this valve so that no more bleed air could come in here, because usually the APU is off in flight, so the bleed air would be coming from the engines. You'd shut this duct off so you wouldn't have any overtemps next to the duct right there. Environmental control units are air conditioning packs. The air cycle machine can get hot, especially if there's a leak inside of it. So there's typically an overtemp warning system on environmental control units, on air conditioning packs, air cycle machines. Landing gear wheel wells. It's not uncommon to have overheat detectors. I've seen, in fact, the A320 has a overheat detector on the brakes themselves. Oh wait, there we are, brakes. In the cabin, although usually in the cabin it's not temperature, it's usually smoke. Lavatory is a good place to have smoke detectors. I think the FAA requires it under FAR 121, and of course it's a felony to disconnect it. Shame on you for disconnecting the smoke detector inside of the lavatory. Cargo compartments are a place where nobody's there, so nobody could let you know, so that'd be a good idea to have maybe some smoke detectors in there. And the avionics bay definitely might get hot if something is shorting or something that is not working very well. So here are the airframe locations for looking for overheat or overtemperature or flame. Basic types of heat detectors. See if I can get it. You don't have to write this down, but here's a system with separate heat detectors. Either one of these, if it gets hot, it's going to close this circuit and go to ground, and the other side of the light goes to the bus bar, which is positive, although this might be alternating current, and of course to the bell. So this could be grounded, the light and the bell could be grounded, and the other side's stuff positive, so they would go off. And of course this is the fire warning test switch that you would use before takeoff. And here's a kind where the stuff inside of this loop, this is actually a really, really long tube, say about 3/32 of an inch in diameter. And the outside metal is a conductor, and the inside is a conductor. And the material on the inside, if it gets hot, it allows current flow from one conductor to the other, and that would turn on something in the cockpit. Here, it's another tube, same size, probably about a little under 1/8 of an inch in diameter, and it just has two conductors in it, and the goop inside, if it gets too hot, it'll allow current flow from one to the other. So this essentially acts like a switch. And there's just a circuit there. And here's what it would look like inside of an engine compartment or inside maybe a cargo bay. It's just strapped down every 6 or 10 inches, and you can see it's not very big in diameter. Smoke detectors. Instead of just measuring heat, you could measure smoke. In cabins and in some cargo compartments, you probably, why smoke detectors there is because you'll probably get smoke before you get flame. You probably get smoke before you get a big buildup of heat. So that would be a better first indicator, would be a smoke detector in these areas. Flame detectors, typically you find those in engine compartments. Flame detectors actually measure for infrared light. And the more infrared light than inside of a closed compartment would mean you'd have a flame, because the closed compartments aren't open to the sun. Of course, carbon monoxide detectors, you're used to that if you're flying little airplanes and somebody's got an electronic or a dashboard sticky that's got a carbon monoxide detector. One could argue that that's not really a flame detector, but I certainly like having carbon monoxide detectors. And of course, like I said before, it might just be a temperature gauge, and that you'll have to monitor because the light or horn won't come on. Typically, and this doesn't have to be engine. Let's get rid of that. Fire extinguishing agents. You got to have heat and fuel and oxygen in order to produce a fire. And you can put it out with water, carbon dioxide. You can use dry chemical, powder, halogenated hydrocarbons, which are typically called halons. But you typically don't find too many water fire extinguishers in airplanes anymore. And CO2 is pretty old school, although there are a few airplanes out there. Mostly it's dry chemical or halon. One of the nice things about halons, unlike dry chemical leaves a lot of residue. And so it's really hard to clean up. Halons, on the other hand, the newer ones don't have much, if any, residue at all. And in fact, the higher numbers, like you might have halon 1100 or 1201 or 1302 or something like that. And the higher the number, the lower the toxicity to humans, so it's not poisonous. It extinguishes better than the old school was, and less residue. So the higher the number, the better in all ways. And there were some examples down there, but you can't see them, but what the heck. They're usually 1100s, 1200s, 1300s. And here's the system that's set up. Here's a couple of bottles, a couple of halon bottles, and this one's designed to either pump to the APU compartment or pump into the engine. Here's a picture of an HRD, high rated discharge type system with typically now halon. And here's an electrical wire coming in so you can blow the squib. Yeah, I like blowing squibs. Get to that here shortly. HRD stands for high rate of discharge. HRD, high rate of discharge. And typically it's halon or carbon dioxide, but it's mostly halon these days. There's very, very few CO2 extinguishing systems out there anymore. It usually only takes a second or two to drain the entire bottle. Once you push the button, and it empties out, it'll be empty in 1 or 2 seconds, but that's good because it'll flood the compartment with the fire extinguishing agent, in this case a halogenated hydrocarbon, a halon, and that'll prevent the fire from burning. It keeps the oxygen from oxidizing, from combining with the fuel. Sometimes this bottle, or this extinguisher container, is typically called a fire bottle. It ought to be called an anti-fire bottle, but it's not. Sorry about that. Here's one, typically pressure gauge on it. And there's going to be a squib, and here I got a nice picture. So here's our fire bottle, and this is going to go to the to wherever the fire is, to the compartment. And so we've got our halon in here. and it's compressed, very high pressure, and you can see that there's a gauge for pressure. Probably can't read the word gauge there though. And there's a screen right here, and the screen right here goes all the way around. And when you allow electricity to go to the squib, this is the squib right here, then it's going to blow kind of like a small gunpowder charge, and it's going to push a blade into this disc right here, and the disc is going to break into a bunch of little pieces, and the extinguishing agent is going to go out, and this screen that goes all the way around is going to hold these little pieces of the disc so they don't get into the compartment. And this is going to essentially open this hole up, boom, and whoosh, it makes that noise. Whoosh, makes that noise. I love that noise. Whoosh. Like a lot of other gases, it changes its pressure in a fixed volume when exposed to temperature. So when you're checking the temperature, you're going to have to, checking the pressure, you're going to have to check it with the temperature. So like, let's just say, for instance, it's 30 degrees, and this one's calibrated in Fahrenheit. So 30 degrees Fahrenheit says that the pressure ought to be somewhere between 209 and 295 psi. Now that's not outside air pressure, outside air temperature. That is the temperature of the container, the temperature of the stuff inside of it. So of course the higher, here's 100 Fahrenheit, it ought to be between 438 and 528. And of course if you're in Minot, North Dakota, and it's minus 40 degrees Fahrenheit, it ought to be between 60 and 145. It's the same amount of gas, it's the same amount of molecules, it's just the hotter it is, the higher the pressure. So when you check the pressure, you may have to pull out this temperature conversion chart and see if there's actually enough halon in the fire bottle. Now, typically on the side of the airplane, very commonly, or let me back up. Fusible plug. Wow, fusible plug. Too many. Fusible plug. It works on the theory of operation identical to that of a fusible plug in a large aircraft wheel, in that it'll melt due to high temperatures to prevent overpressurization. And here shows one right here. There's a piece of metal in here, and it melts at a low temperature. If it melts, whoosh, whoosh, wow, there's the whoosh again. Whoosh, it lets all the halon out before this thing here blows. So it's a safety precaution. Now, if it does that, then typically what's going to happen is, what you're going to have happen is this red disc, it blows if the temperature got too high and you prevented overpressurization. This disc will actually be blown out. You might see remnants of it. The yellow disc, on the other hand, the yellow disc, this is hooked into the fire extinguishing, and right here. Here's the fire extinguishing, and this is to the compartment. And here, I'm going to get wild and crazy, man, here, and get a yellow disc. And here's going to be this yellow disc. And there's just going to be a little tiny hole. Got to change colors here. There's just going to be a little tiny hole right here. So that the vast majority, 99.99% of the extinguishing agent will go to the fire. But a little tiny bit will blow out this yellow disc. So if the yellow disc is blown, it means either on purpose or accidentally, somebody fired this squib, the frangible disc broke, and the halon was sent to the compartment where it was supposed to go. So yellow blowing out means the system was operated. Doesn't mean there was a fire, just means somebody operated it. And if the red disc is blown out, it means that the fusible plug melted and allowed the gases to escape before it got overpressurized. And of course, this is the APU fire extinguishing system on a 737. So here we got our PSI we can check. And of course, we have a backup to let us know whether or not the system was operated or the system was depleted due to overtemperature. If you have any questions about airframe fire protection systems, you know how to get a hold of me. You got any suggestions for improvement, you know how to get a hold of me. And you know about doing the connections. Thank you. Bye.